What is up YouTube, and welcome to episode 7 of the Cyber Bike project. Today we are taking a break from making brakes and going to give you the breakdown on how brakes work, or at least the ones that I made. Spent quite a bit of time yesterday working on these brake calipers. Going to be a nice long time lapse for you. And yeah, it was like all in all 5 hours of combined work that I've had to condense into like 9 minutes of time lapse. So enjoy!
Money. Money. Money.
Oh boy, now that was a lot of work, wasn't it? So I bet you're wondering how these doodads work. Well, that's a good question. They're actually pretty simple. They're a lot less over-engineered than what most brake pads that I've seen are. The most interesting part is how the oil channels work. I had to use a bit of trickery to get this to work. It's okay. I might change it in the future when I'd get some more information about stuff and learn a few more things. But the key thing is they're supposed to move. Why no move? Oh, that's right, I have that. I can do this. If you don't know how to do this, this is called driving constraints. You create constraint and you can drive constraints, and then you push a button and look at that. How cool is that? Yay! Anyways, so let's show you how these things work. Pretty simple. We shall switch to side view. Now, I hope everybody can follow along. I'm used to working in wireframe and stuff. It can be confusing with some complex parts where there's lots of bits everywhere. Yeah, so how this works. On the one side, which will be this side here with this hole, this is the outside clam. You have two halves to the brake caliper like a clamshell. This is the bit that's on the outside. This opening here will hold a pin that will travel. There'll be a pin, the banjo bolt that we discussed in the previous episode. There'll be a banjo bolt that runs from the outside to this point here on this side here. So this banjo bolt will have the hydraulic pipe connection to it, the hydraulic fitting. So the pressure from the master cylinder will come down to this point here and will travel through the center, through the pin that holds the two brake pads in place, and to the other side. And on each side, from the bottom of each of the clams, there is a hole drilled up to on that side and on this side. And these holes are plugged up with hydraulic nipple, the bleed valve. At the moment, I just have some grommet screws in there because they don't have bleed valves in the content center. I'll have to make some up. So that's what it looks like from the side, where you have the one input and it travels through the caliper to the other side so that there's equal pressure distributed to both sides of the caliper. And if we look at it from the other view, when it travels through here and comes up this channel here, there's this plug. So this gets drilled out and tapped with a hole, opens, it cuts into the two cylinder sides on the sides here, and it comes up through this hole here. So this splits then the hydraulic fluid from the input to the two cylinders to equalize the pressure, and it's the same on the other side. So that's a very simple way to create these enclosed spaces without having to make very complex casting molds and die casts and stuff. This whole thing can be made from billet aluminium and machined completely with the billeting process. It'd be easier to cast most of the clam in a form and then just put it through a machining process to clean up some of the edge, give it some fine edges and stuff, drill the holes and to ream the seats for the cylinders and the O-rings. But all in all, that's pretty much it. It's a very basic design. Anyways, so yeah, that was it. That was a day's work. We have functioning brake calipers. The only thing missing are things like O-rings, the hydraulic brake fluid, what do you call it? A hose fastener? Or some, I don't know. And the banjo slash pin rack and pinion bolt that runs through, that gets held through these holes here. So you can see there where it comes through, and that's where these two pads slide against. I still need to make another spring steel clip that also sits between the two pads here, and it comes up above this edge here around the side, and it just keeps the two pads in alignment and stops them from shifting back and forth. So yeah, that should do it for today's episode. We've gone through quite a bit there with brake calipers and all the aspects of how brake calipers works, the engineering behind it, all of the different complicated things that have to come together to make several moving parts work together to stop you from crashing into stuff. So yeah, next episode we're going to start working on the front swing arm, and that's going to be a lot of fun because there's a lot of information and interesting topics to go over with steering geometry and how steering geometry affects the performance and handling of a motorcycle. What are the different kinds of steering geometry? Talking about rake angle, how does the radius of the tire interact with the road surface at different points in function? Like for instance, when you're moving slowly and you're turning the handlebars to steer when you're like pushing it around, or when you're moving at speed and you have to lean the whole bike. How does the interface between the road surface and the tire work with the angle of the rake and the total angle of steer on the steering yoke? So yeah, lots to go over, and I hope you guys enjoyed the last couple of episodes. I've had some feedback from one of my viewers, and she's given me some help getting this camera looking better because it was a bit fuzzy before. I couldn't figure out how to get it to dial in, and now yeah, so hopefully this camera's looking good too. Yeah, I've been Chaos, and until next time, I'll see you guys later.